Well, we moved from radiograms and homebrew transmitters. I must get on with that valve tester as well. Right, well, radios don't get better than this. The Rotel 230, it's coming direct from an eBay sale. M5 Communications, Granada Services, Exeter, Devon. We better give them a ring, because I'm going to break their seal from 1996. There's every chance. I mean, I've been around since 1979 in business. Right. Well, a good chance that this is going to be quite splendid. In the same batch there is a Cybernet. No, it's not. It's a Ford Roadmaster, the small Ford Roadmaster. And there's also a very sorry looking Maxcom 4E, which will probably turn out to be the best set. There's a couple of SWR meters and a broken looking Cybernet mic. And it's 5:45. This just arrived 5 minutes ago. And the first problem I can see is we're going to have to put a fuse in this. And it just so happens that my cluttered bench has got fuses. And it just so happens that we need to install a new fuse holder. Right. No problem. Well, what we'll do is we'll connect the negative of my famous crocodile clips that regularly short out to there, and the positive to there. And we'll switch on, we'll connect it to the test equipment. We've got a signal generator on order, one of these cheap Chinese ones, 50 quid one. And you know that one I've been using for as a marker oscillator, which I think's 12 meg maximum. We'll order a 30 meg one of those, so it seems to work very well, so we'll see if it works very well in its 30 megs form. Okay, so we're connected up. Oh, well. It's coming and going. Why is that? It's not that, is it? I think we've got a situation with the negative that it's so corroded. We'll just cut that end off and just strip a bit back. I think it's been in a garage or something. You know, I do about 250 CB radios a year, and I would say 2/3 of those are like this, you know, 1981 era sets. And that's 250 sets a year that aren't going in the bin. You know what? Yes, we've got a capacitor needs changing. So when you see a capacitor which looks like it's been for a circumcision, that has been overvolted. So it's probably been in a vehicle which has gone over 16 volts for some reason. Having that said that, I think we need to deal with that one as well. That's not as bad, but it's starting to recede. That's fine. Right, well, we'll plug the mic in and we'll just see the filthy mic. I think we can put that through his own dishwasher, don't you? Oh, I don't know about... We don't do mic repairs, but you know. I think we're going to be starting to levy a £3 repair charge for mics. Okay, let's see how it is then. Rather stiff volume control. We need a new piece of paper. That was easy. Hymns from last Sunday, yesterday. Haydor Church. Well, I'm not going to waste new paper, am I? So are we on the Cat's Protection pen today? Rotel RVC230. So I'll just pop this camera back out to its normal position. And let's see what transmit power we're doing. So I'm on the 3-watt scale. We'll switch picture in picture on. So full scale deflection and will be 3 watts. Boing, it's well across. Right, I'm now on the 30-watt scale, so 4 watts with my best Cat's Protection League pen is just there. That's 5, that's 4. Oh dear, it's doing 4.5. So we'll have to turn this one down, but there's a procedure, of course. I'm at 13.7 volts, which is fine. And we need to start by doing the VCO. So, power. Let's just see if we can do the deviation while I'm at it. Wallow, we're not tuned in. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. You know what? I don't think there's any transmitted audio. Let's put the monitor receiver on. Testing 1 2. Testing 1 2. Nothing at all. Well, what we'll do is we'll use our test mic and we'll fix his mic later, for which there'll be a £3 charge. First time I've levied that since 1996. 1 2, testing 1 2 1 2. Let's have a see whether we've got deviation now. 1 2 1 2, or whether it's actually the radio. Well, I can see it doing something. 1 2 1 2 1 2. Wallow, wallow. 1 2 1 2. Why aren't I reading it? One two one two 1 2 wallow. Strange. Well, that's the President Randy 3 on the floor. Testing 1 2, testing 1 2 1 2. Wallow. No, there is no deviation on the radio. Alright, we'll get back to doing the VCO then. So I need to connect my negative lead to negative power because it's a floating chassis on a Cybernet set. Yeah, I tell you what, I get a lot of comments about, especially from people in other countries. I had this with the Rotel 240. It's just like the such and such in another country. Yeah, well, Cybernet do. They did the radios for all over the world, so the limited number of case styles. So you find the same radio may have been in the United States. You might find a set which is AM and SSB, and then you might find exactly the same here, which is FM UK. And I had a comment from somebody, and he said, "Can you convert it back?" It's never been converted. It was it's a totally different board. You know, if you buy a Toyota Corolla in America, it's left-hand drive, and if you buy one here, it's right-hand drive. It's not being converted. Right. So what we want, I think it's channel 40. I'm going to have to get that service manual out because my sieve-like memory, and I don't know where the nice one is. Not lost, I promised the kind person who sent me. This is getting really tatty. So test point 1, it's 4 volts. Test point 1 is 4 volts. So we're on channel 40. And we're at the far end of resistor 4. So that's no good at all at 1.97. So we'll just adjust the VCO. And that doesn't feel promising. It's been in somebody's garage so long that it doesn't feel like it wants to move. So what we'll do the transmit side. That needs to be 4 volts as well, if we can get our prod back on. I'll just go round in circles with this so it kind of cleans itself, and then we'll start again. Well, it's slightly low. It's got a nasty spot where we actually want it to be. So we'll have it at 3.8 for transmit. Now we'll go back to receive, and I'll just pop the soldering iron down there and just give it a little bit of a warm up without touching the plastic sides. That's it. Back to transmit. That's now totally different. So we've got 3.95 on receive, and we've got 4 volts dead on transmit. Incredible. Now we just need to verify that it's somewhere where it should be. Is it 1.8 to 2.5 on channel 1? So that's 2.2 on receive. That's 2.38 on transmit. So we're spot on. I've said before, if we don't do this, you can end up within a temperature range. You can end up with channels dropping out. You know, like when the car's cold, a bit like that latest model blue Midland 78 plus multi we have in the test card is, even though they're all like that, they're awful for that. Nice radios, as long as you don't mind it waiting for 2 seconds for it to go into transmit. Okay, so now we'll need to peak it to maximum. And yeah, it's still got to be peaked to maximum, because although it's over power, it still needs to be at maximum on. I need to make sure it's on channel 20. That would be a schoolboy error. So with the green tool, the 3 coils here, that, and that, which I'll tell you the numbers, L4, L8, L9. So maximum, and that's exactly what it was, maximum. Next one doesn't want to move. This is the wrong tool, but I'm old enough and ugly enough to be able to make it work. So that is peak. So this radio has been at maximum, and that isn't how it works, because what happens is you end up with the channels lopsided. So let's just see, on channel 20 I've actually made no difference to this radio. It's still as peaked as when it came in. I have made no difference. So it's 4.5 on channel 20, 4.5 on channel 40, and 4.3 on channel 1, which is actually quite good going, to be honest. Anyway, what they want you to do is they want you to adjust L4 clockwise to get 4.4 watts. Well, that won't take much doing because we're nearly there. So back to channel 20. Legality aside, you don't want to be thrashing anything. You know, you don't want to be driving around in your car with the pedal to the metal, and you don't want to be... There we are. So now we're at 4.4. And now what you do is to take L9 anti-clockwise, and the manual says 3.8 watts. Well, we're doing 4. And now it should be, and remember this is on a commercial meter, so that 4 watts is probably 6.5 or 7 Zetagi pretend watts. So on channel 40 we've now got 4.1 watts. On channel 1 we've now got 4.05 watts, and on channel 20 we've now got 4.05 watts. So we'll leave it there, because as it warmed up, of course it drops off. So that's fine. That's as high as we're going to have that. So while we're playing with that, let's get the meter set. It's going to be banging across, isn't it? Wow, bang. So with the preset there, we'll get that set to read 4. So whilst we're playing with the power, we'll switch the 10 decibel attenuator on, so it should now be 0.4 of a watt. And at the moment it's doing 0. Let's have a look. Not a lot. That would be 1 watt. So it's 100 milliwatts it's doing at the moment. It wants to be 400 milliwatts. There we are at 400 milliwatts. Switch that back to normal. Now we've got a snag with no deviation. Well, the first thing we need to do is to make sure that that one is in the center position. Voila. Now I'm going to put a monitor receiver on, because obviously there's a snag with this. Okay, testing 1 2, testing 1 2, 1 2 1 2. So we've got no audio. We'll just check if we turn the deviation up. There's still no audio. Wallow. So we have got a problem. That can be the audio IC. It can be the speech processor chip, which is the operational amplifier there. I think it's that one there. It could even be that capacitor. So that's going to get changed anyway. So we're going to now abandon transmit. That's got a fault. That needs fault finding. So it's now gone from being a retune and test to a repair. So we'll dial in 2779125 into the signal generator. Oh, I'll tell you what we'll do. We'll just check it's on frequency. So I'll just put the camera on there. Should be 2779125. It's 2779115. That's neither here nor there. That's spot on, to be honest. We'll just adjust it that little bit. The wrong way, of course. There we are, 2526. That's great. So receive. Let's just get back on with that, and we'll go over to the sign. We'll go over to the synad meter. Okay. Tell you what, that's excellent. 0.24 microvolts for 12 dB synad. I don't think we'll probably be fixing it worse. I've told you that story before. What we will do, we'll put an S9 signal on. So I'll put the oscilloscope on and turn the bench light off. Turn the volume down so it doesn't annoy somebody's dog. And we'll just check that our recovered audio with the detector coil here, which is in the corner, that's spot on as well. There's a lot of spot on this radio. Okay. So we'll see whether we can actually gain anything. Do the front end. There's a bit more signal on so we can do the IFs. I doubt that's made any difference. No difference whatsoever. It's not often we can't get anything extra. So, S9, 100 microvolts in the UK for a CB radio. That should be S9. And it's reading S8. So we'll just pop that up. It's the preset there. S9 it is. Squelch. Just put squelch to full. And I want the squelch to come in at 100 microvolts. So full squelch. So 1, 3, 10, 30, 100 microvolts. That's where I want it to come in. And that's where it does come in. That's spot on. If I needed to adjust it, it's the preset just there. So we'll now park the signal generator at 0.3 of a microvolt and we'll turn it to standby. We'll now turn the squelch down on the radio and set it to threshold. We'll now switch the signal generator on and we'll see when it comes in. So it's coming in at 0.49 of a microvolt and it's leaving at 0.4 microvolts. And that's typical for the performance of a Cybernet 134, so that's fine. So we need to change those two capacitors and find out where the audio's gone. Now that one could affect it, but we'll change that first. That's our first little port of call before starting worrying and looking at the circuit diagram. I'll let him clean this setup himself, but when we come to the Maxcom 4E, I think I'm going to respray it for him, just for a laugh. So we need to get that capacitor out. I'll turn the power supply off. Change glasses. So positive towards me. 220 microfarads at 16 volts. We'll just see what we're reading on here. .220 is a bit high. They start to do that when they're starting to fail, but I'm changing that precautionary. So this is the one which would affect audio if indeed that's what's been happening. Put a 35 volt rated one in just to make it more reliable, because it's only 38 years old. You wouldn't expect it to go wrong, would you? So positive towards me. It actually smells of damp, this. Smells of coal cellar, to be honest. do that one, which is scary. Is that the right one I'm about to bounce on? Yeah. It's always going to be somewhere awkward, isn't it? So it's negative towards the back, positive towards me. Yeah, it's just a bit high, but it definitely needs to go. And fun enough, it's exactly the same value, 220 microfarads. Right, well, I don't think that's going to make the slightest bit of difference. So we'll bring back our test mic, put the power supply back on. Switch on the monitor receiver. Testing 1, 2. And switch on the radio. Testing 1, 2, testing 1, 2. So, tell you what, quickest test ever is to stick my finger on a metal screwdriver and touch the deviation control. So it's transmitting. Well, look at that. There you go. So if I press on that, it works. Hello, testing. I think we've got a actually broken control. Okay, what's there? I don't think that's managed to unsolder just there. I've gone and unsoldered the wrong one. That's really smart, isn't it? I'm glad I'm not in space jettisoning the wrong thing. Well, you know, I'm not messing about it, but with it's fallen apart anyway. But how much of that is existing, and how much is that is desoldering and taking it out? Anyway, we better be careful with this and pop it back in. It's a weird type, that. Right, we'll go to stores department and 2K by the looks of it. I'm just going to verify with the service manual. So it's RV2. Yeah, 2K. Pause the video. Right, so while you weren't looking, I thought we'll get that new one fitted. So that's now in. UK source is... just trying to tell you who it is. And Rapid Electronics, Rapid Online. Because all the RS and CPC, they do the more expensive enclosed types. And then you don't fit the printed circuit board properly. So if you're building a project from scratch, you wouldn't use what they call skeleton presets, you'd use the enclosed type, but we need to replace like for like, really. Let's take that back to that meter. So I've every faith now that when we switch on it will work. Testing 1 2 1 2 while it does. Excellent. Right, we'll look at the deviation meter, turn that off. Put it about there. 1 2 wallow. 1 2 1 2 wallow. It needs to just come up a fraction. Let's just give it a bit more. Wallow. 1 2. That's fine. So it's one preset, 2 times 220 at 35 volts, just so we know what to bill him for. Right, so that's everything. We just need to check his mic. One, two, wallow. Do you know what? His mic doesn't work. Testing 1 2, testing 1 2, 1 2 1 2 1 2 wallow. 1 2. So you see how you've got 2 faults there for no transmit. The radio doesn't work, the mic doesn't work. But chances are, I bet there's a wire got pulled out of there because it's pretty ropey. I wonder where my normal screwdriver is for this, because when I come to do that teeny weeny screw, this big screwdriver is not going to be any use. There we are. Aldi's best set. I can't even take the plug apart. No, it must be all rusted together inside there. So we'll chop the plug off a little bit back, throw it in the bin. I'm not trying to pick up sales, honest. Yeah, you can see it's green. So of course I might now go to the trouble of rewiring this and then discover that there's still no audio because there's another problem. Okay, so here we've got the new plug. I recovered the sleeving. We do have this somewhere, but you know, it's not here. So I tend to start by putting the teeny weeny screw in first. If you ever lose these teeny weeny screws, you know Knights at Curtin and Lindsay sell teeny weeny screws, and if you need to search for them, they're called teeny weeny screws. Now I put a piece of sleeving so that it grips better. Most mics aren't like that. I just think it adds something for the strain relief. Right, for the moment of truth. Voila, it works. We'll back that monitor receiver back. Testing 1 2, testing 1 2, Wallow 1 2, testing 1 2 3 4 5, Wallow. There we go. So that's got the original Rotel mic going. So we changed the two capacitors because they clearly needed to be changed. We've changed the preset because it was broken, and we've sorted the mic out. So we put the lids back on, and he can enjoy himself cleaning that. We'll have a scratchy corner test in a moment, but probably in about an hour, and as soon as I put these lids on, we'll just run around the channels and discover nobody's on. So when I look at the serial number, it's 317, so it's quite a low one. We'll just need to do that fuse holder, but that'll have to be done on another bench. So, usual off frequency people, we know why they're off frequency. 1 Roger. I won't get one of those, will I? Right, we'll park it at 31, ready for Mr. Chippy to do a test with us, and jam the usual screwdriver underneath it. There you have it, the Rotel 230 fresh off eBay, delivered straight to me, and it's a nice radio. Well, it is when its case has been dealt with. Thank you for watching.